Welcome to the video for skill number 31 of Unit 5, Properties and Attributes of Triangles. Skill 31. I can apply the Pythagorean theorem, its converse, and the Pythagorean inequalities to triangles. We'll begin our notes on page 05-19, and we will title it Pythagorean Theorem. Skill number 31. I can apply the Pythagorean theorem, its converse, and Pythagorean inequalities to triangles. The Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the legs of a right triangle. In our diagram of a right triangle, we have angle or side A, side B, and the hypotenuse is side C. So the square of the hypotenuse, c squared, is equal to the sum of the squares of the legs. A squared plus B squared equals C squared. Here's a nice little graphical representation of one particular case for the Pythagorean theorem. Our A value is 3, our B value is 4. So 3 squared plus 4 squared is equal to C squared. And in this case, we find that C equals 5. Going beyond that, example 1. The legs of a right triangle measure 8 inches and 15 inches. Find the length of the hypotenuse. So if we have one leg is 8 inches and the other leg is 15 inches, we're looking to find the length of the hypotenuse. So our A squared plus B squared equals C squared is translated into 8 squared plus 15 squared equals C squared. After doing the arithmetic, we arrive at 289 is equal to C squared, and we can square root both sides and find that 17 is equal to C. We might have another example where we're given a right triangle and we're told that the hypotenuse is 13 and one leg is 12, and we want to find the other leg. So for this equation we would have x squared plus 12 squared equals 13 squared. If we start to solve that, we get x squared plus 144 is equal to 13 times 13 is 169. So then x squared equals 25, and we find that x is equal to 5. The most basic problem, we're given the two sides and we look for the hypotenuse. A slight deviation from that, we have a side and a hypotenuse, and we need to find the second side, or rather second leg. On page 520 we see the converse of the Pythagorean theorem, which basically says if a squared plus b squared equals c squared is true in a triangle, then the triangle is a right triangle. So Pythagorean theorem is if we have right, then a squared plus b squared is equal to c squared is true, and the converse is the opposite. If a squared plus b squared equals c squared is true, then we have a right triangle. We can use the Pythagorean theorem with inequalities, and this is when we get into the Pythagorean Inequalities theorem. And what this states is, in triangle ABC, we'll assume that C is the longest side, and if C is the longest side, then if C squared is greater than A squared plus B squared, then triangle ABC is obtuse. More importantly, the angle opposite C is the obtuse angle. Similarly, we can state that if C squared plus A squared, or C squared is less than A squared plus B squared, then the triangle is acute. And we'll see an example of how to use the Pythagorean Inequalities theorem on the next page. For now, let's take one last look at something about the Pythagorean theorem. There are certain sets of numbers which are called Pythagorean triples, and this occurs when three non-zero whole numbers satisfy the Pythagorean theorem. For example, 3 squared plus 4 squared equals 5 squared. So 3, 4, 5 is a Pythagorean triple. Or 5 squared plus 12 squared is equal to 13 squared. That is also Pythagorean triple. Alright, let's look at an example which uses the Pythagorean Inequalities theorem. Example 2. Tell if the measures can be side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right. So right now we don't know what type of triangle we have, or if we even have a triangle. So step 1, we actually have to prove whether or not we have a triangle. And we use the triangle inequality theorem. We learned about that in the last lesson. As you recall, the triangle inequality theorem says that side 1 plus side 2 is always going to be greater than side 3 in any triangle. So we try it out with our three numbers. 15 plus 17 is greater than 30. That's true. 15 plus 30 is greater than 17. That's true. And finally, 17 plus 30 is greater than 15. That's true. So we do know that we have a triangle. From here, we apply the Pythagorean Inequalities theorem. So what we're going to do is we'll take the longest side and let that be our C. And we take the two shortest sides and let those be our A and B. So we're looking at the relationship between A squared plus B squared in relationship to C squared. So my work here shows 15 squared plus 17 squared is somehow related to 30 squared. And we simplify that equation and we eventually arrive at 514 is less than 900. So by the Pythagorean Inequalities theorem, we are able to say the triangle is an acute triangle. For skill test 31, what we will need to be focusing on being able to do is, first we should be able to draw a right triangle and label that right triangle in such a way that we can write the Pythagorean theorem, a squared plus b squared equals c squared. Notice my triangle is not right until I put the square in the corner. We should also be able to apply the Pythagorean theorem and apply the Pythagorean Inequalities theorem. Alright, this concludes our lesson for skill number 31. Thank you.